In this video, we will look at simplifying expressions with exponents that are negative. To set this up, we will consider a cubed over a to the fifth. A cubed means we have 3a's in the numerator, and a to the fifth means we have 5a's multiplied in the denominator. Reducing out our factors, we notice everything divides out of the numerator. When everything divides out, we know we are left with a 1. A 1 in the numerator, and a times a, or a squared, in the denominator. However, we could have solved this problem a second way. We could have solved the original problem using the quotient rule, which says we subtract the exponents 3 minus 5, which would give us a to the negative 2. Notice that our negative exponent is the same as 1 over a to the positive exponent of 2. A negative exponent simply means all the a's have divided out in the numerator, leaving a's behind in the denominator. This gives us our negative exponent rules. A negative exponent simply means we flip the base. In the first case, a to the negative m, moving to the denominator, and now the exponent is positive. If the negative exponent occurs in the denominator, this means the leftovers will be in the numerator. We get a to the m, over 1 in this case. If the negative exponent is on a fraction, this simply means we must flip the entire fraction. The b's are now left over on top, the a's are left over on the bottom, and now we could consider the exponent of m, and probably take this one step farther using the power of a quotient rule to get b to the m over a to the m. Let's take a look at some examples where we can see simplifying by moving factors around that have negative exponents. In this expression, there are several negative exponents. It's important to remember that negative exponents are only going to affect the factor they are attached to. This means the 7 does not have a negative exponent, just the x. Similarly, the 3 to the negative 1 and z to the negative 4th have negative exponents. Negative exponent means we have to move it either from the top down or the bottom up. Let's build this one piece at a time. We have a 7 in the numerator. X to the negative 5th means it needs to move to the denominator. Now it is x to the positive 5th. Looking at the denominator, 3 to the negative 1 means we need to move that 3 to the numerator. Now it's 3 to the positive 1. The y does not have a negative exponent, so it can stay in the denominator. Z to the negative 4th, however, must move to the numerator, making the exponent a positive 4. Finally, we can simplify by multiplying the numbers to get 21z to the 4th over x to the 5th, y. Let's take a look at one more example, where we can see negative exponents moving the factor it's attached to the opposite side of the fraction. In this expression, we've got a to the negative 4th. Notice that exponent is only on the a, not the 5. This means the a is the only thing that will move to the other side of the fraction. We have a 2 in the numerator, and a to the 4th moves to the numerator. A 5 is in the denominator. It is important to notice with these negative exponents that the negative exponents never made numbers negative, never made fractions negative. Negative exponents simply move the factor to the opposite side of the fraction.